In this video, we're going to look at drawing Lewis structures and assigning shapes using the Vesper theory. Here are the rules to follow when drawing Lewis structures. You're going to add up the valence electrons for all the elements involved. You're going to do this using the group number from the periodic table. If there is a negative charge, you're going to add the same number of electrons as the negative charge. If there is a positive charge, you're going to take away the same number of electrons as the positive charge. You're going to arrange the atoms evenly around the central atom. You're going to begin with single bonds between each element, and remember, each bond represents 2 electrons that are being shared. Then you are going to fill the octets of the outer elements, and remember, some just need 2 electrons, like hydrogen. And then you're going to fill the octet of the central atom. You may need to use double or triple bonds, just never exceed 8 electrons around an atom. I think it's best to look at some examples. Here we have nitrogen trihydride, or ammonia. So if we look, nitrogen is in group 15 of the periodic table. That means it has 5 valence electrons. We have 3 hydrogens, and each hydrogen has 1 electron. So we have a total of 8 electrons. So we begin by putting nitrogen in the center, and the 3 hydrogens arranged fairly evenly around. We begin with single bonds between the nitrogen and the hydrogen, and we have used 6 electrons total of our 8. Hydrogen is happy if it only has 2 electrons, which it has with those bonds. So we are going to add the 2 electrons onto our nitrogen. That is the Lewis structure for ammonia. Carbon tetrafluoride. Carbon is in group 14, so it has 4 valence electrons. We have 4 fluorines, and fluorine is in group 17, so it has 7 valence electrons. So we have 32 electrons. We begin by placing carbon in the center with the fluorines spaced evenly around it. We begin with single bonds, and that has used 8 of our electrons. Carbon's octet, you'll notice, is also complete at this point. So if we begin to fill the octets for our fluorine by adding our electrons, you'll notice that we end up using all 32 of our available electrons. And so that is carbon tetrafluoride. The ammonium ion is NH4 1+. So again, nitrogen is in group 15, so it has 5 valence electrons. Each hydrogen has 1. And this time, because we have a positive 1 charge, we're actually going to take away 1 electron, giving us a total of 8 electrons. So if nitrogen goes in the middle with the 4 hydrogens around it, and then we place our single bonds, we have used all 8 of our electrons. Because this is a charged compound, we put square brackets around our drawing, and the charge goes outside. Using Vesper to determine shape, you should have been given a table that looks something like the one below. You need to be pretty good at drawing Lewis structures, and you need to be able to count the number of things around a central atom. And what you'll notice is that electrons and elements are treated basically equal. So let's look at some examples. Here's a Lewis structure for ammonia again. So around the ammonia, you have 1, 2, 3, 4 things. So on your chart, you go down to steric number 4, because that's just a fancy word for 4 things. And then you're going to proceed across the table until you find the thing that has a central atom with 3 elements and 1 lone pair. And you'll notice the shape there is trigonal pyramid. And that's it. If we look at water, H2O, around our oxygen, because we always look at our central atom, there are 1, 2, 3, 4 things. So again, you're going down to steric number 4, and you are going to go across until you see the central atom with 2 elements bonded and 2 lone pairs. So this one is bent. Our final example is carbon tetrachloride. So again, around the carbon, you have 1, 2, 3, 4 things bonded around it. So you go down to steric number 4 and over to this area because it is one central atom with 4 things bonded. So the shape of this is tetrahedral. If you still need assistance with determining shapes or looking at Lewis structures, ask your teacher if you can use a model kit in class. Just before we finish this video, let's just discuss symmetrical versus asymmetrical, because this is going to be important for future lessons. We consider a molecule symmetrical if it falls in this category. Because what you'll notice is that in our first column, we have no lone pairs. If you have no lone pairs, that is considered symmetrical. Everything else in this VSEPR chart is asymmetrical because the central atom has lone pairs of electrons. I hope this has helped you learn how to draw Lewis structures and assign VSEPR geometry.